So we've come to the desert here in Wadi Rum, and you're going to teach us something about 3D mapping. How do we turn a 2D map into a 3D map? Something, say, like this guy here. How could we turn that into a map?
Well, the first thing we need to realize is that a map doesn't just have two dimensions in it. Yes, it is a flat piece of paper, but embedded in that flat piece of paper there are values for a third dimension, for altitude. And that's what we're going to try and work with today. So there's a really easy way of doing this using some really simple pieces of equipment. The first, here's one I did earlier, are these skewers. And I've marked these off with 12 different delineations. And we're going to take each one of those lines as 10 meters. So we're going to use those to help build our 3D model. The next bit is that embedded 3D information I was talking about. So in each map you've got, at each point on that map, we've got some kind of hidden value for altitude or for elevation. So this is what I've drawn out for this hillside right beside us here.
That one there?
Exactly, this large hillside over there.
Okay.
So I got values for this hill in meters above sea level.
Yeah.
Now I've adjusted these to make it easier for us to do today. In reality, these are going to be thousands of meters above sea level because we're in the Wadi Rum.
Okay.
So for each one of these points, I'm going to slowly build a grid using these skewers in a third dimension.
And then they represent the elevation from the ground.
Exactly. So what we're going to do is we're going to draw a grid into this sand, just like these figures.
Yeah.
And at each point, we're going to descend a skewer into the sand to that particular altitude.
Okay, and is that it?
One more step, because then on top of those sticks, we're going to drape some kind of surface. Because at the end of the day, this grid is still just that. It's just a grid. A 3D surface doesn't become a surface until we cover it in some kind of continuous sheet or scarf. And that's what we've got here. So I'm going to use this white scarf to drape across our sticks once we've made that grid on the sand below us.
And then we'll be left with a model of that big protrusion there.
Yeah, so with any luck it'll look quite similar. I don't want to paint my scarf though.
Okay, let's have a go. Let's check it out. Brilliant.
So I'm going to draw a grid very simply into the sand here, and that's going to allow us to build our 3D model. Okay, so for each one of these skewers, we've got marks all the way down their length. And we're going to take each one of those marks as representing 10 meters in altitude or elevation above sea level. So I'm going to push those skewers down into the sand to represent our particular altitudes at each point on our grid. So we've got 6 by 5 points on our grid, so we've got 30 points on our grid in total. If we refer to our sheet, we can see we've got our values here that we're going to try and represent with these skewers all the way across this grid. So our first one on the top left is 60. So we're going to push this down so that only 6 of these divisions are visible. So that'll represent our 60 for that corner over there. So this kind of concept is exactly how they'll make the surfaces you might see in a 3D computer game. If you're playing Call of Duty or whatever, you can see the hillsides, you can even see the buildings, and this is exactly how they'd make this. They'd use points of particular altitudes, in that case code and computer language, but then on top of that they'd drape some kind of surface, like the hillside you'd see in the computer game, the buildings you might see and walk through. Drape our scarf down on top of this, and then this should allow us to fill in the gaps in values, because at the moment all we had was point values. This scarf or this surface allows us to fill in those values, so it takes a guess of which value is in between those two sticks and turns it into a 3D surface. So you can see we've got the high point of the hill here. It tapers really fast down on this side, just like it does in the real world. And then it gently tapers down the back on this side. And you can see that it's a tent basically, it's hollow. And that's exactly what a 3D model of any surface on the planet would be. It will be hollow. You're not going to look at the underground here, we're not looking at the geology. This is just giving you the 3D surface, whatever's on top that you can see. So by using our grid of values that have come from our 2D map, we've been able to use the skewers to represent those altitudes that are represented by these figures, and then on top of that frame we've placed some kind of surface, which in this case is my scarf, and that's allowed us to represent very simply something that's 3D. We've taken it from the wild, our 3D mountain, and we've placed it right here at a much smaller scale.